guys, so today we're going to take a look at the fundamental theorem of algebra, which is building upon what we've already learned previously with our solving of polynomials. So previously, when we were solving our polynomials, we were given all real solutions. Everything was either a whole number, a fraction, or an irrational radical value. But as we know, we don't always have real values. We might have imaginary solutions. And the fundamental theorem of algebra is going to help us determine, well, how many solutions do we have? Are they all going to be real? Are they going to have some imaginary solutions? And to make sure that we always find the correct amount. Okay. So first thing we're going to do is we're going to practice just solving. Make sure we know how to do that because it's going to build, as I said, into what we're looking at with the fundamental theorem of algebra. So in this, we noticed we had a degree of 1. We have a linear solution or equation. We found its solution, and there's only 1. We had x squared minus 2. That's a quadratic, a degree of 2. We have a plus minus radical 2. That's 2 solutions, 1 positive, 1 negative. X cubed minus 8. Well, we were able to find 3 solutions for that one. We had 2. And we had a negative 1 plus I radical 3 and a negative 1 minus I radical 3. And then our last one, still we had a cubic, a degree of 3. We had 3 solutions, 1, negative 1, and a negative 1. We had 2 negative 1, so it repeated. Technically, those are 3 solutions. So what you should notice, if you haven't already caught on, is that the degree equals the number of solutions that we have. And that is our fundamental theorem of algebra. Basically, if I know the degree of a polynomial, then I know how many zeros I'm going to expect. And again, it's going to be both real and imaginary zeros. So when we look at polynomials, and this is what we're going to do in class, you just need to know your degree. Whatever the degree is, that is how many solutions you are going to have. So if you were to graph it, say you had a quartic function of 4th degree, you graph it and you only see 2 zeros. Well, that's going to tell me I have 2 real ones. Those are the 2 that I see on the graph, but then 2 imaginary ones as well. So I need to make sure I'm always aware of how many total solutions I should be coming up with. So I'm not stuck with only giving the real solutions that I might visually see on a graph. Okay. And again, remember with things like quadratics, they might never even touch your graph. They might never touch the x-axis, which means they're all going to be imaginary solutions. Okay, so we want to keep that in mind as we go through this chapter. And we're just going to, again, continue to practice. We will graph these. We're going to look at them, like I said, wherever they cross the x-axis. If we see it crossing once, but it's a degree of 3, then I know I have 2 remaining solutions that are imaginary. If it doesn't cross at all, and it's a 4th degree polynomial, then all 4 of my answers are imaginary. Okay. If it's a quadratic and I see it crossing 2 places, then they're all real. So that's what we're going to take a look at to begin with. Just deciding how many solutions do I have and what types of those solutions are there going to be. Then we're going to get into finding those solutions. So we're going to use the rational root theorem, again, to help us get started. If we can't factor it, then we're going to use the rational root theorem to come up with our possibilities. We're going to graph the function, get those real ones that we can see, and then use the synthetic division to help us with solving it continually. Okay. Again, we might have to repeat synthetic division a couple of times. If we go through and we're still stuck at a point I can't factor, go back to your graph, find another real solution that you can do another set of division on until we get to a point where we have found all of our values. So as you can see here, I have one completely done out for you. I can see it's a degree of 5. So that means I should have 5 solutions. Yet when I look at the graph, I only see 2. I see it at a positive 2 and a negative 1. So again, Desmos graph is going to be our best friend here. It's going to help us really narrow down these solutions. So I take the 2. Actually, it doesn't matter which one you do, So I took the 2 and I did my first round of synthetic division. I got to a point where I didn't know how to factor that. I don't know how to factor x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. I just don't know how to do that. But I can do another round of synthetic division because I had another number I could use. I had that -1. So I take the -1, I do a second round, and it gets to me at a point where I can actually factor, right? I have 1, 1, 4, 4. I can factor x cubed plus x squared plus 4x plus 4. I can break it down. I have x plus 1 and x squared plus 4. And then from there, I can simply solve it, okay? I found that my x minus 2 gave me the positive 2. I saw that. X plus 1 gave me a -1. X plus 1 gave me another -1, which, had I noticed, that -1 bounced off. That means it's touching. There's 2 of those. So that was 3 out of the 5 possible solutions, which would make the last two be imaginary. And that's where my 2i and a -2i would come into play. And when I count that, there's 1, 2 for the positive negative, 3, 4, 5. There are my 5 solutions for my degree of 5 polynomial. Okay? And again, we'll be going through practicing a whole bunch of these throughout it. And then the very last thing we're going to do is, again, a repeat of what we did in the previous section, writing the polynomial from given zeros. The only thing is, before I gave you real numbers, gave you whole numbers, or radicals were attached. Now we're going to have some that have an imaginary number. Okay, so the same rule applies with the imaginary number as does the radicals. So remember our conjugate theorem. If I had an a plus radical b, then I have an a minus radical b. Same thing applies here. If I have a plus bi, I also have to have an a minus the bi, or whatever is attached to that I value. You have to have one positive and one negative. Because again, remember, if I go back to that previous problem here, when I square rooted a -4, we have a positive and a negative I value. Okay, so again, you would need that when you are writing your degrees. And then again, we multiply everything out. We put them in their factors, multiply it out just as we did previously, and come up with our function. Okay. And again, just a reminder, you're treating I just like you did with the radicals. So we grouped together our whole values, the x and the whole number, and then we grouped together our radical as a square when we were multiplying it out. Same thing's going to happen. Remember, the I is just a square root of -1, so I can still treat it as I did the multiplication with any radical. And that's why you can see here that x minus 3 got grouped together. They're identical. And then the i's got grouped together because they're identical. All right, and then again, you would multiply it out, square things. And just a reminder, when you square an I squared is a -1 because you're squaring a square root of -1. And as we know from the previous section, when we square a square root, the inside falls out. So the inside was -1, it's going to fall out. And then from there, everything is normal. And this is our new section. Again, it's basically a repeat. It's the section we just did before on solving polynomials, but now we have those i's involved. We have the imaginary numbers involved because they are part of our solutions.